Hi, everybody. It's noon, June 24th, 2025. And it's time to do another LeetCode problem. So let's just jump right into it. Okay, today, let's do the hard problem we skipped yesterday. So this one is regular expression matching. Given an input string S and a pattern P, implement regular expression matching. I feel like I did this one before. Yeah, I'm pretty sure I did this one. I haven't saved a lot of my problems, but I'm pretty sure I did this one. So let me look at a different problem. Strange, I didn't mark it as finished though. Yeah, I would expect it to be. Maybe there's a different regular expression problem, but I did something very similar. Should I do that one? Yeah, let's just do it and see how it is. Oh, interesting, they give you comments. Okay, but basically the idea is you have a pattern to match. The pattern has to match the whole string, and you support dot, which means match any character, and then star, which matches the preceding element. So dot star means you can match anything. So dot star should always return true, given that string is always a valid string. Pattern's only up to 20. Okay. Oh, this is probably what I did. Maybe I haven't solved the problem. Yeah, this looks like my writing. Maybe it saved my writing? Okay, let's delete that. Maybe I didn't pursue this problem for whatever reason. Okay. But basically, we're going to iterate over the string. Looks like we only have lowercase English letters, dots and stars, so that's nice. And you never have a star starting the string, so that's nice too. So basically we only have to consider valid input. And let's, the examples they gave are pretty small, but it gets interesting when you have like 2 items like this. So this would match for example, this would match A. And note if you had this string would match B because the star allows for 0 elements, right? matches A. Okay. So you can think about the star as like an option. You can match something, but you don't have to match it. And there's no grouping, so that's nice. You don't have to like handle multiple characters with a star. Okay, so it seems like looking for the stars are going to be important. Yeah, because that's the part that's variable length. Everything else is a fixed length. So how about look for stars? Then do we just try to match the stars? I think you should try to match the regular string first. The non-star part of the string. So with the stars, we know which character we are starring. Okay. And let's say we remove those. Now we can try to match the non-star part of the string. So for example, if you had, let's say your regular expression was B A star B, the non-star part is just BB. Right, and then means you could match something like BB or B, B. But the idea is to ignore it. You could also match EB or 100 Bs, but you would not match 1B. Or for example, A. Yeah. Okay. Note with the case when you have something like if you have so one thing you might just try doing is just greedily going for it. So let's consider the greedy approach. In this case, greedy approach. Start, iterate over string. I thought of some other examples. It's interesting that you start with the thing, with the variable length thing. So this could match A or AA, right? Or A infinite A's. is at most 20, so even if we're n-squaring it, it's not really that bad. But it does feel like we need some dynamic programming if you have multiple long entries. Anyway, the greedy approach. It's not ideal, but sometimes it reveals something that lets you find the better approach. Let's try that. Iterate over the string. Match parent elements. Regex. So while you're iterating our string, you have to iterate over variable match iterate over the variable match if we are so that means first, for example, for this case, we would try from 1 to 20 A's. Which actually would be efficient in this case because we try just one, then we'd recurse and go to the next one. Yeah, I'm gonna just try that approach. So for the dynamic programming part, we could, I don't know if it's dynamic programming, we could break the problem up into little sub-problems. Another quick thing you could do is that would reject a lot of bad strings, might be important if it's longer, is you could just take a set or a count of a histogram of the characters and make sure they're the same for the non-star characters. Because the non-star characters represent a minimum that you'll need. Yeah. So that's interesting. We haven't talked about the dot yet, but I think the dot's pretty flexible. But yeah, the greedy approach doesn't seem so bad with a length of 20. Or I guess you start from 0 for the variable match, 0 characters matched. So let's just do that. C and S, no. So how do we iterate? two cursors, we need the I'm thinking if we should translate the pattern into the actual to like reduce the stars. But we might not need to. Let's try without it. Okay. S cursor equals P cursor equals 0. Yeah. For C and S. S cursor no, I think actually we don't have cursors because we're recursing here, which will be reasonable at just 20 items. We won't blow up the stack. Okay, so look at P. All we care about is the current token. So pattern cat equals P0. Is star star equals P is true. True if when P greater than 2 and greater than 1, P1 equals star. Yeah. Okay. So that is great. If we are not star, I'll have to handle the is star case. So if we're in a star, what we should do is evaluate 0 match case. And that just means we do like it's the same string, but the next character. And it's the same match, but from 2 characters. Yeah. Okay. Now we have to evaluate variable length matches. Okay, so variable length matches, we just are basically iterating over we're doing a while. while should be whether or not the thing is true. Okay, so we want to look at S. Okay. So we start at idx is 0. I think we just use a for loop here. No, I think we need the index. We can do for idx enumerate s. So I'm going to enumerate over the string and check so the dot is a special case. We don't care, right? We don't, it matches anything. Okay. Or we want to check that we want actually the negative case because we want to stop this loop when we don't have a match. Right? We just break. And the other cases is when we can recurse. So that is match. So now, sorry, the zero match case should not consume string. So that was a mistake. So that skips the substring as well as the current pattern character. All right. Okay, and these things should return true or false. So if they actually return true, what is the terminal case? So when we have empty string and empty pattern, right? Yeah, let's think about what the base case here is. Eventually we're going to consume all of the string. We have empty string. And we may or may not have empty pattern. If we have a non-empty pattern, so if we have a non-empty pattern, we're going to hit this case here, so we're good. If we have it, if we've consumed all of the patterns and all the string, then we can return true, right? That's the only case. So the base case here is do it before. If not P and not S. Right? They're both empty. Now the case when you are LF, if you don't have, we need patterns. Yeah. I think this is it. So we only evaluate the terminal conditions when we run out of patterns. And when we run out of patterns, then we terminate. And I don't think this is it a break? So this break here is kind of like a false. It means we didn't match. So the danger here is I want to make sure if we don't have a match, we don't keep just going. We should be able to terminate early. Yeah. These stars could also be implemented by just filling up the pattern buffer with a length of characters. But I'm not gonna, I don't see a real advantage to doing that. Okay, so here's what we're doing. Excuse me. If the pattern character okay. I think this is mostly okay. We didn't handle the not. The star case, and that's basically, I think this is where we terminate early. Right. If the pattern care is not equal, what's the, I mean, it's this case again. And instead of breaking, we just return false. thing just doesn't match. Otherwise you recurse. And you recurse by taking just the current character off. Yeah. All branches return something, so that's acceptable. Except here, you don't necessarily. If you break, when you run out of matches in your sequence, you break here. So when you're done with the loop, you're still having all the matches are false. Yeah. Mostly, I think this is the idea. Let's try it out. If pattern character is not equal, there must be a syntax error here. Do not have the right number of spaces. Oh, there's no character defined. It's just a 0. Okay, so we missed the very base case. I mean, we were able to handle one case false, probably turning false everywhere. Okay, so A star didn't work. Let's debug this. If star, so we're going through the string. We have valid P, so we don't hit that case. The pattern character here is A, and length P is greater than 1. Yes, length is 2 in the pattern, and this should be true. P1 should be true, or is a star, so this is true. So if star is true, great. So we go on to if is star. And then we try to match the 0 case. Let's just ignore that because we're actually interested in this case here. So we're going to enumerate over the string. Let me just quickly verify I have my enumerate correctly. Okay, let's just run and debug it this way. So if we only were able to loop once, so we're breaking way too early. We should be enumerating over the whole string. But apparently we were breaking here, so if the pattern character is that, is not that, is not dot, the pattern character is A, right? This is a not equals. Right, it's only not was helpful to debug. Okay, I'm gonna put that stuff back in. Let's see. We're still not getting it. This time we get through 2, so that's great, right? Okay, so the second time around, we're still matching that A character with the pattern character. That second time around, we are now passing, oh, you know what? The IDX is a +1. So it starts at 0. We want to skip the first character. Yeah. So that was probably the mistake. Let's try again. All right, so that worked. I'm going to YOLO and submit it. Looks like we crashed some things. Let's put this test case here so we can try it. So the test case is A, B, and the pattern is dot star C. All right, let's run. Yeah. So we are going over the edge. And the line we are going over the edge is, yeah, so this +1, possibly this P2 should be safe. So because we guaranteed we have at least 2 in the length. I'm a little unclear why this would push us over the edge of the string. We're handling the dot star here, right? Yeah. So we have dot star C, and we're in the star here because we're printing out the stars. Interestingly, we never got to the C. So we're taking S, and here IDX is 1, that's the last standard out. This looks valid. String S has 3 characters. No, S has 2 characters, sorry. Okay, I see. Okay. Trying to look at this. It looks like the one it's actually complaining about is line 39. So we did get into the C case. That's because you can see the stack has 2 entries. The first one's for the star. Second one is for the empty pattern. Or sorry, the C pattern. Okay. Yeah. So there's another case here where if not S and false, handle empty string. And mismatch. Okay, so I think that will handle that case. I'm gonna comment this guy out and run. Yep. All right, let's submit. Okay, so this works. Looks like we are not using a lot of memory, but our runtime is horrible. Let's try to think about how we can improve now before we go to the LLM. First, was there anything I wanted to look up? I was a little worried that my enumerate usage had the index flipped, because that's something easy to forget if you're not coding daily in Python. Yeah, but no, everything else I think is pretty reasonable. And just to confirm, yeah, you can slice using the length, which is beyond the last index, and you should just get an empty string as a result. Yeah, so no real technical things to look up, but how can we make this faster? So where are we wasting all the time here? Well, there are a few things. I mean, there's like hack type things we can do that I don't think are useful for this particular case, but maybe. I mean, maybe. So the things we can do are like the histogram-based matches. That's fairly quick to compute, and that way we can eliminate a lot of obviously incompatible strings. Like this case with a C in it in the pattern, and there's no C in the string, that should be rejected quite easily. But the real question is, can you go down from this n times m approach that we're doing right now? The worst case is if we just have a lot of stars. The pattern string is just dot star, dot star, dot star. Then we're basically doing an n squared over 2 type thing. So yeah, what would be the correct solution there? I guess, I mean, this is more on the hacky side, but if you see 2 dot stars, you can merge them into a single dot star. There's no real different. If you see I think that's true. If you see adjacent dot stars, or if you see a dot star followed by a character star, you can also merge those. Which is kind of interesting. But if you see 2 character stars that aren't the same character, then you can't merge them even if they're adjacent. If they're the same character, you can. Yeah, but those are on the hackier side. I mean, it's probably worth discussing them, noting them to show you're aware of that. But I feel like there might be another way to approach this fundamentally. Like intuitively, it seems like if you have the non-starred characters, you should be able to use those as anchors, because those need to occur in the resulting string. Or you won't be able to match. So yeah, that could be a way to limit the dot star expansion, or even the star expansion, right? So for that case, let me just write some comments down and try to sketch it out. Master, anchor, fixed characters. But the tricky part is that because of the dot stars, each fixed character could apply to various points. Yeah, but it's probably less of an issue. Yeah, so one idea is you can look ahead when you're doing the dot star stuff, or when you're doing the star stuff, into the next character in the pattern. Same approach, but be generous. I don't know if this is the right term, but I mean anti-greedy with star expansion. When you see a character that matches, next pattern continue with that pattern. Okay, so I'm going to try that. Let me just save the solution below. Okay, so what this means is, so we're iterating, right? Don't we already do that? Let me see. Because this is match is passive. Like the first thing we test is with the next pattern, right? Yeah, the very first thing we test is with the next pattern. Well, I think we are running out of time anyway, so I'm just going to take this solution, add the description. And then put it into ChatGPT to see if we can So this solution in an interview, I'd probably not be happy with the results, even though it's correct. It's probably missing a few things. I mean, those hacks I came up with would probably speed it up in some test cases, but I think there's something else. And yeah, this is one nice thing about the LLMs. And we can also look at the existing solutions, since we are now asking for help. But I'd like to see if a little help would show us. So one thing sometimes I see is the LLMs marking my solution wrong when it's correct, because I haven't told it explicitly that I validated the solution, or at least it passes the tests. But yeah, we can ask it for a test case that would fail. Okay, so the string is BAAB, and the pattern is A star AB. This should fail, right? This doesn't seem like a counterexample. This is not a match. My code passed the submission tests already. Pretty sure it's Claude. Sharpness. You see correctness issue, give me counter the test example. The one you gave with should return false. There is no D. Let's see. Okay, so yeah, maybe Gemini's not so good for the hard problems yet. that's a nice diagram. I like that. That is great. Okay, now it thinks I have a clever solution. Well, that could just be as syncophancy. Okay, yeah, so this is a dynamic programming or cached based approach that could help things out. Yeah. Or memoize, that's the term to use. I want to memoize the result. Okay. So memoizing the result. There's a nice, wonder if we can use decorators here. What is it? It's like function utils. I'm gonna look this up. Okay, so you just do at cache, and that should work. I might have to import it, I'm not sure, but let's try that. Oh, looks like did I have it right? Was it at? It's at cache. All right, let's try that. All right, there we go. The cache-based approach. I mean, they might ask you to implement that. I mean, depending on the language, you'd have to, but basically you just have a dictionary, a global dictionary that looks at S and P, keys on some combination of S and P. You could just concatenate them together. No, you can't concatenate. You can concatenate them together with like a separator, like a comma. If you just want to use a string key, you could also just use a tuple. And save the result. Cool. All right, so pretty happy with that result. One thing I want to look at is Gemini said the complexity is exponential, and I was looking at it as n squared. Or n times m, rather. Yeah, but it's true for these like longer recursion problems. We end up checking the same string multiple directions. I thought the greedy approach would cause it to consume faster, but now I see maybe that's not the case. What I mean is that we have this isMatch 0 here, so we're not actually reducing the string. One thing that could have been interesting if we started backwards, so we save the evaluate 0 case until the end. But I think you'd still hit these problems at some point. Yeah, but it could be that if you start with the fuller strings, this is less of an issue. And as to why that is exponential, it's because each one of these asterisks will have all the other asterisks blow up, so it is more than n squared. Yeah, it is exponential. All right, I think this is good. Thanks everybody.